Hola a todos hermosos y hermosas, ¿qué tal? ¿Cómo estáis? Bienvenidos a Las Cosas Retro. Hoy tenemos un vídeo muy especial, pero que muy especial. Básicamente, esto que tengo aquí es un prototipo de un AMSTRAD CPC. Y este es el Project Manager del proyecto de cuando se creó este prototipo.
And this is Retro Things.
Comenzamos.
Las cosas retro son lo mejor.
Bueno, pues vamos a empezar ya con esta entrevista que no voy a dirigir yo, porque tenemos aquí a gente muy especialista del mundo Amstrad. Entonces lo tenemos por aquí detrás, a Jaime, que es redactor de la revista Retro Gamer, creo que es una revista que muchos de vosotros conocéis. Y también tenemos por aquí detrás de azul a Pablo Forcen, que es miembro de la Asociación de Amigos y Usuarios de Amstrad. Bueno, también decir que Jaime también es miembro de la GUA, que es el grupo de usuarios de Amstrad. También agradecer a Jorge, que fue el que me invitó a poder estar aquí. Jorge es el organizador de Retro Alicante, la feria que se hace cada año aquí en la provincia de Alicante. Y nada, sin más, vamos a empezar con esta entrevista tan interesante a esta persona, pues que es un maestro. Adelante.
Según Wikipedia, Amstrad fue un fabricante de electrónica con base en Brentwood, Essex, Inglaterra. Empresa fundada en 1968 por Lord Alan Michael Sugar en el Reino Unido. El nombre es una contracción de Alan Michael Sugar Trading, Amstrad. Entró en la Bolsa de Londres en 1980 y a finales de la década de los 80 Amstrad logró hacerse con un 25% del mercado de ordenadores en Europa. Durante la década de los 70 lideraron el segmento de la alta fidelidad, televisiones, radiocassettes de bajo coste, amplificadores de audio y sintonizadores. Fue en la década de los 80 cuando Amstrad entró en la Bolsa de Londres, doblando su tamaño y comenzando a comercializar sus propios ordenadores personales, intentando capturar el mercado que en aquella época tenían Commodore y Sinclair, con su primer microordenador, el CPC 464, en 1984. En esta entrevista a Roland Perrry, el Project Manager del proyecto Amstrad CPC, el padre, a él no le gusta que le llamen así, el padre del CPC, nos va a contar todos los secretos de la creación de este icónico ordenador de los 80. Esta entrevista comienza un año antes del lanzamiento del primer CPC, en 1983, con su prototipo, sí, el prototipo del CPC 464, el que Jorge, el dueño del lugar donde estamos grabando y organizador de Retro Alicante, es poseedor de una de las 45 unidades que se fabricaron. Y así, con su libreta de apuntes de cuando Roland Perrry estaba diseñándolo y con el mismísimo prototipo, comenzamos a hablar con él.
We are here with Roland Perrry and we are going to ask him some questions, Pablo Forcen and me. And the first one, Roland, is as far as I know, the first time you saw this keyboard, you were not an Amstrad employee.
Correct.
You were working
I was working for Ambit, and we were a company that did many things, but one of them was helping people develop prototypes for computers and radios and audio and things like that. So.
And you were selling by mail
And
components?
we're also selling our money on day to day came from selling electronic components to the public. They could come to us and buy transistors and chips and things like that. And the reason we got into that business is because big semiconductor companies had minimum order of 100. So if you wanted to build one radio, you couldn't go to the chip seller and say, could you sell me one power transistor or one chip to make the radio? They would say, no, you've got to buy 100. Right? And so what we did was we would buy 100, we keep 1 or 2 for ourselves and sell the other 98 to other people who were desperate to buy them because nobody else would sell them the chips one at a time. So we were like a wholesaler. We took the big tube of chips and split it up and sold them one at a time to people.
Were you the technical manager in that company by that time? Technical assistant or?
Well, my job at the company was IT manager.
All right.
Okay, because we had 5 or 6 young ladies who spent all day on the phone typing invoices, printing out delivery notes for the components we were selling, and we decided, or William Pole decided, that he wanted to computerise that. Okay, and so at the time I was working in a company in Reading, selling exactly the sort of computer that he wanted to buy, and they were very expensive. I mean, we've talked earlier about the multiplier, but the sort of computer that I sold him was £10,000.
Yeah, a lot of money.
A lot of money.
Yeah.
More
At that
than a really fancy car.
Yeah.
Not quite as much as a house, but more than a really fancy car. So every time I sold one of these, my job was selling these computers to businesses. And every time I sold a computer to a business, they said, why don't you come and work for me and be my IT manager? And I'd say, no. My job is selling people like you these computers, and I can't be IT managers for more than one company at the same time. All right, and I've no idea what your business is. All right, and therefore I'm going to sit here and sell people like you these computers. And they all said, oh, all right then. And they went off and found a different IT manager. One day William came knocking. He's an old friend of mine from school, so I knew him. And he said, I want to buy one of your computers. Oh, will you come and be my IT manager for it? And I thought, oh, okay, I've been doing this job 5 years now. I need a change. Yes, okay, I agree. So I left that company and built him the biggest computer of its type. It's like an IBM PC, had like slots in the back. The IBM PC's got what, 5 or 6 slots? The ones I was selling had about 20 slots. All right, and he bought one with every slot with something in it. So it's quite an expensive one, and so I configured it for him, sold it to him, moved to Brentwood, became his IT manager, and I wrote the invoicing software, the order processing, the stock control software, because if somebody rings up and says, I'd like to buy a thingy, then it's quite helpful to be able to say to them, oh, actually we don't have any of those in stock at the moment. We're getting some in 3 weeks' time. Is it okay for you to wait? And they'd either say yes or no. Or we'd say, actually, as it happens, we've got 20 of those in stock and we're very happy to sell you one of them today. Right, so you need immediate. So our job, well, my job, was to write the software. They typed in and it said, yeah, that's in stock. Yes, in stock. Oh no, actually that's one's, we're not even sure we're ever going to get any more of those. But maybe the customer will wait anyway, right? Because there's nowhere else they could have bought it. And so anyway, so we, so I'd pretty much finished writing that software. And we had, I'd say, 5 or 6 order processing clerks typing the orders in, 5 or 6 in the warehouse,
Yeah.
taking the delivery notes, going around one of these, 6 of those, 4 of those, and putting in a jiffy bag, label off in a mail bag.
So, Bob Watkins.
So one day, every year we had to do a stock take.
Yeah.
Okay, because the auditors and the tax man wants to know how much money you're making.
Yeah.
And it's no good, if I put my accountancy hat on, you can only work out how much profit you've made if you add up how much you've spent, how much people have paid you, and what is the value of the stuff in your shop. So once a year you have to go round and work out how much it's all worth, because it's gone up in value since this time last year. Then that's money you've made, and you need to put it in your accounts and pay the tax on it. If it's gone down, then maybe you pay slightly less tax and all the rest of it.
Here.
So, and because most of our customers were hobbyists, okay, the busy season was in the winter, because they'd all sit at home when it was dark out, cold outside, and they'd make their little electronics kits. And in the summer, particularly in August, they'd all be off on holiday, so nobody wanted to buy anything. So our business went up and down like this. Okay, so we always did our stock check in August. Okay, so we were there one weekend in August doing our annual stock check, and up turns Bob Watkins on a Saturday morning, which is a bit unusual. But we kept the shop open. We had a little trade counter.
But you knew Bob Watkins?
Yes.
Because Amstrad had ordered something before from
yeah,
you.
we'd helped him with other,
With radio.
with CB radio, I
CB
think.
radio,
CB
yeah.
radio and a couple of other things. Also, one of the things was the components we sold in the shop to the amateurs, right, to the, were not all brand new from the factory. Okay, if you're somebody like Amstrad and you have a factory that's making colour televisions, and you want to make 1,000 colour televisions, you buy about 1,100 parts to make them, because you know 5% of them are going to be broken.
Yeah.
But you don't know in advance whether it's 4% or 6% or 5%, so you buy about 10% more. When you've made your 1,000 televisions, you've got this pile of stuff left over.
Yeah.
So what do you do with it? Well, actually, you sell it to a man who then sells it to people like we were, who comes round and says, "Oh, I've got a couple of hundred of this. Are you interested in buying those and putting them in your catalogue and things?" So we used to come round once a week in a white van, absolutely full of bags of these end of production line clearance things.
All right.
And that's where we got a lot of our stock from. Not the chips usually, but the things like capacitors and resistors and switches and knobs and all those sorts of things.
And Bob Watkins?
And Bob Watkins, so he came round, we were there doing the stock check. We had a trade counter, right? So you could not just write to us or phone us up to buy something, you could come to the trade counter. And the trade counter was open 6 days a week. Okay, so we were always there on a Saturday anyway. So we'll work 6 days a week. And so we were sitting there doing the stock check on a Saturday morning, and Bob Watkins turns up and says, "Hey guys, you know something about computers, don't you? We've got this project here which we really need getting done, and the people doing it for us have basically given up. They walked off the job. Like, they thought they could do it, but it turns out they can't. So we're in a bit of a hole here. Could you finish this off for us?" And I looked at it and I thought, well, actually, I've been wanting to do something like this for years.
Did you?
Yeah. I thought, no, that sounds quite interesting. I don't know if it's possible.
Yeah.
I don't know how long it's going to take. You need to give me a week to work out whether it's possible and how long it's going to take. But I'll give it a go. So I'll spend the next week just running around doing a feasibility study for you, which is what I did.
You could always run to the district lake if you couldn't finish the...
That's right. Well, no, I wouldn't. I'd just hand it back to him and say, "There you go, Bob. You know, I gave it my best shot, but I can't find anyone to do this for you. So, you know,
So,
see you again in another couple of years."
it has been said you are the Amstrad CPC father. but you prefer to be seen as a film director.
Yeah, that's right. People always, my very first passport, I got a new one to come here,
Yeah.
and what they want to know is, what is your profession? And I go, well, there's no word for what I do. I do so many different things, and it's so unusual. And so I put down computer programmer.
Computer programmer,
Yeah,
not technical manager or...
Because that was on their list of
Oh, right.
jobs you could pick, right?
Oh,
And
okay.
so the passport people understood what computer programmers were. So, computer programmer. But people are always asking me, what is your job? And the only job title that I could ever find was technical manager.
Technical manager.
It's very general thingy, but I used to think of it like a film director. Okay, so Alan Sugar's the producer. He's the, I can't remember the name of the guy who does all those films, but anyway, who's the director? Who's the producer of Titanic?
James Cameron.
James
maybe?
Cameron.
Yeah.
So he's the James Cameron.
Yeah.
All right, but you can have the idea, you can find the money, you can gather everybody together to do it, but somebody has to actually do it. So I'm like the film director.
Yeah.
Right, so I say, right, this is the plot. All right, you are the actors, you're the cameraman, you're the sound guy. All right, you're doing the props. Okay, you're doing the costumes. Everything you can get an Oscar for, basically. Oh, you're doing the music, all right? And so my job was to find the people who would design the costumes, compose the music, be the cameraman, and all the rest of it.
And was that easy for you to find those people?
I was very lucky that I just managed to find those people fairly easily.
Okay.
Because I knew people who did those things before. So I was thinking, well, actually, I need somebody to be a costume designer. Oh, yeah, actually, I remember somebody I used to know who
Nice,
can
nice.
do that. So you bring all the people together
Yeah.
and you put it, you make it into. But something that helped enormously was that I wasn't just a film director. I was also a part-time cameraman and a part-time sound guy and a part-time costume director.
Yeah.
All right, and so if somebody was saying, I'm a bit stuck on this costume, a costume is like the user manual
Yeah.
or the welcome tape. And if they're saying, well, I'm a bit stuck on this, I would say, well, actually, I've done a bit of this in the past. Why don't you, I'll help you. Oh, that's a good idea. They'd say, right, well, so I'd always be nudging people in all these specialities in the right direction.
Okay.
And it was you and William Powell from Ambit, and also Chris Hall and Richard Clayton from Locomotive.
Yeah. So William Powell was he's the guy that founded Ambit, and I'm his friend from school who went to work with him later. His role at Amstrad was mainly user club, software, customer support, things like that. But he's very good at that. So he did that little bit of it, right? But that's after sales service,
Yeah.
really. But for a computer to be successful, you can't just put it on the shelf and say, oh, there's a computer, why don't you buy that? Because the parents who who is now spending a month's salary buying the computer,
My father did.
they want to know, well, are there any games for it? And is there a user manual? And when you get it home, can you show it to us doing something? So you need the welcome tape, because when your father gets home, your mother says, what have you spent all that money on? you silly man. And he said, well, look at this welcome tape. It's really great. It does lots of stuff. And she'd say, oh, well, I suppose so. And that was actually quite important, because a lot of computers that you bought back then, all they sold you was the computer.
Yeah,
and then
that's-
said, oh, you want some games for it? Well, we've got no idea. Well, we bought the computer off us now, so we don't care. But we cared right from the very beginning, because we knew that you had to have all that stuff. And that's where Alan came in, because he was the guy who said to us, look, it needs to have a manual, games, a welcome tape, a user club, and all the rest of it. So why don't you go off and organise all that? And so we did.
So those were the specifications by Alan Sugar?
Yeah. So he
Games,
Yeah.
business
Yeah,
computer
that's right.
appeal.
That's right. He had a whole list of things which the computer should do, like on the back of this computer here, which I'm sure you show pictures of later, was a printer port. Okay.
Were you by that time when you were designing the CPC? Were you looking at other computers?
Oh yes, yes, absolutely.
Which one, Commodore
absolutely.
or Sinclair, or which one was your, your reference, your biggest reference?
The biggest references were the Commodore 64,
Yeah.
the Sinclair Spectrum, and the Acorn Model B BBC computer. But also there was a computer called the DAI,
Yeah.
which wasn't terribly well known, but was designed. It was sold in the Netherlands,
Yeah.
and it just so happens was designed by a friend of mine. Complete coincidence. And he's one of the people I went to see, and I said, look, you've done this computer for DII, whoever they are, would you do one for me? And he said, well, I'm a bit busy at the moment. So I said, okay, I'm not going to force you. And then I went to my friend at Acorn, and one of the funny things was, in those days, all these people designing computers and things all talked to one another. It wasn't like they were competitors.
Yeah.
So it'd be like somebody, say you'd be designing a Jaguar car, and you'd go and talk to your friend who works for Lamborghini or BMW and say, I'm having a bit of trouble with my engine, would you help me out? And they'd say, well, of course we will. Right, whereas the commercial people would go, my God, you can't do that. We want their cars to be as bad as possible. We're paying you to build our cars, not to build their cars. But all the computer people, we all talked to one another. So I went and saw my friend at Acorn, and I said to him, well, I know you probably can't help me because you've got a full-time job at Acorn designing stuff, but do you know some people who might be able to help me? So he gave me a little list of people, and they were all already kind of social friends. We've all been at university together and things like that. And he sent me off to the guy who was running the Sinclair QL project.
QL.
Right, which didn't end particularly well.
Yeah,
it wasn't his fault, but the QL is a computer which got cost cut to the point that it didn't work anymore.
Sinclair, so.
Anyway, and you must watch. There's a TV program. It's on YouTube, and it's called Micro Men.
Yeah,
that's got a lot about that. Anyway, so I went to talk to my friend who was working on the QL, and he said, "Yeah, well, we're a bit busy trying to get this QL working at the moment, to be perfectly honest. If you weren't that busy, maybe we'd help you." And so I went to my friend who designed the DAI, and he said, well, I'm doing other stuff now. And then I had the BBC Micro has an expansion port.
Yeah.
And one of the things that you plug into that is a second processor. Okay. And one of the products that Acorn was working on at the time, which they outsourced, was a Z80 second processor, because it had a 6502 in it.
Yeah.
And their idea was that you bought the keyboard, you've got everything like that, but you're not 100% happy with only having a 6502. So maybe you'd like to run some Z80 programs, maybe you'd like to run some Motorola 68000 programs. So they had a development program of various second processors.
Yeah.
So I went to the people who were designing a second processor for the Acorn, and that was Chris Hall and Richard Clayton, Mark Jones. Well, actually, Mark Jones wasn't working on the hardware, he was just a friend of theirs. It was Chris Hall and Richard Clayton were working on the second processor. So I went to see them, and I said, would you like to help me out on this project? This is the last, with the end of the week, the clock's ticking, last chance saloon. And they said, yeah, I think we nearly finished that one. We'll come and work for yours, but only if you tell us who your client is. And I said, well, actually, I've been told not to.
But Richard, he saw it on the board?
Yeah, he saw it on the board because I'd replaced this with Arnold in that same typeface, right? And he opened it up and saw Amstrad on it and thought, never heard of them. So he put it back together again, and so I said, well, look, okay, but
you were all in Richard's house at that time. It was a single moment in time when you meet and decided.
Not quite. I went to see Richard because he was working from home in Dorking, and showed him the thing and said, well, would you, because he's a software person, because we knew we needed a basic software. We couldn't buy, for example, Microsoft Basic because it was too expensive and didn't work very well. Right. I went and talked to the people who did the Spectrum Basic, okay, and they weren't interested. They said, oh, we've done the Spectrum Basic, we're sick of Basic, we're doing other stuff now, so we can't do a Basic for you. But he was doing the Basic for the Z82nd processor. Okay, so I went round to his house in Dorking and sat and showed him, and he said, oh, okay. And he said, well, you need to tell me who your client is. And I said, well, actually, I've been told by a very stern man under no circumstances to reveal who the client is, but it's a big electronics company and I trust them. All right, and if you trust me, you'll trust them too, until we can actually all get in the same room together. And so he said, oh, okay then. And his business partner was Chris Hall, and they said, well, that's all very well, so we'll do the Basic for you, but who's doing the hardware? And I said, well, actually, I haven't found anybody yet. Okay, and they said, well, we've got this friend Medj who works around the corner, and he's very good at Z80 hardware. He's done Z80 hardware designs for lots of people, but he doesn't like 6502. So one thing you've got to do is change it from 6502, because Amstrad chose 6502 because it was in the Commodore, and they thought it'd be easy to convert Commodore games, which had by far the most number of games to us. So had a 6502 in it, and the Apple's a 6502 as well. And so that's why they chose 6502. But I had a hardware engineer who only did Z80. I had a software company who had a Z80 Basic and said, we'll do your 6502 Basic, but it will take us a year. All right. So I had to go back and say, right, I can do this project for you, but only if you change it to a Z80. By the way, the Spectrum's got a Z80 in it, so there's plenty of games which will be just as easy to convert. Okay, and that's what and the decision to sort of do that was taken in the pub down the road from where.
In a pub.
So me and Richard Clayton went off to the pub, and Chris Hall arrived, and Medj arrived, and we all sat around and said, okay, well, we'll give this a go. And I said, what I'll do is I'll put all this together, and it's in this book here. I'll put this all together and I'll send them a telex at the end of the week and say, this is the proposition. You know, we've listened to what you've said, we know what you want. We also, with all of us, actually always wanted to work on a project like this, because there's nothing particularly wrong with the BBC Micro, but there's some stuff they did that could have been done differently. And we don't hate the Commodore 64, but there's some things about it that, you know, with 2 years later you might have done differently. And again, you know, Sinclair Spectrum's okay, it's really bad build quality, but it does stuff. But we could, if you'll promise to do better build quality and change a few things. So we had all of those machines. We're building on the knowledge, we're building on the, so I don't like to say the mistakes they made, we're just building on the experience that have been accumulated based on what they did and what the customers accept.
And sorry to repeat this question, but you decided to keep the 650, the CRTC, sorry.
Yeah, the
which is more.
It's just a completely.
It goes everywhere.
It's just a completely standard chip. Everybody used it.
And now another question. Did the Elan Enterprise computer was an inspiration?
No, it wasn't. It was a complete pain, all right, because it's what we call nowadays vaporware.
Yeah.
Right. They drew up a spec. They said we're going to launch the best computer that there's ever been, and they just couldn't do it.
Yeah.
They just failed to deliver it. They failed to deliver it, but people said to us, "Well, why are you launching a computer when in 3 weeks' time the Enterprise Elan's going to come out and it's going to, you know, kick you out of the market?" And we said, "Well, actually, if you think it's going to come out in 3 weeks' time, I've got a bridge I can sell you."
Okay.
And they never did. They never really did get to market. I think they may have got a few hand-built prototypes to market, but
At the end, but several years before.
yeah. So yes, it was.
After.
It had lots of. It probably had a better specification on paper.
Yeah.
Right, but if you can't actually design it and build it and deliver it at a decent price, what is the point?
Yeah.
So the colors of the 464s
Yeah.
weren't inspiring on the Enterprise, or what
No, again,
because, you know, they look very similar. You know.
Again, got absolutely standard CRTC,
Yeah.
and basically you do 16 colours in low resolution and 2 colours in high resolution.
Yeah.
Okay, and something in the middle which nobody ever uses, right? Like 4 colours in
Yeah.
mid, but nobody ever uses that. And so we just use that because it's not 16 colours; it's 8 colours,
Yeah.
and the same 8 colours a bit brighter. It's not actually 16
Yeah.
different colours.
Yeah.
Okay, but we had to use that because it was the standard chip, and everybody wrote their software for it, and they were cheap to buy, and everyone understood how it worked and things like that. Later on in the project, somebody who worked for Medge came to us and he said, "I have this great idea. You think you've only got 16 colours, I can make that into 27. We said, "Well, how do you do that then?" And he said, "Because instead of just on and off, I can do you halfway on. And if you mix together some colours which are on and some colours which are off and some which are halfway, you get 27 colours."
Okay.
And so we said, "Well, we'll take that." And we said, "Well, how much does that cost?" And he said, "Oh, it's going to cost you 6 resistors, which are 1 cent each." And so we said, "All right, it's worth 6 cents a computer to do that."
So you were open to third-party developments. You even encouraged them, but at the same time, you kept a close design in some aspects, like the 7-bit printer port, or there are no 5 volts on the joystick port, which is incompatible with the Atari joystick
Yeah.
port. Yeah.
You can plug an Atari joystick into it.
Yeah.
Yeah, so the Atari joystick you can plug in, all right? Again, we added about 2 resistors, so you can plug in a second joystick.
Yeah.
Well, we'll
Yeah.
take that. The printer port is absolutely standard. The problem with the printer port, some people criticise, it's only 7-bit, but that's because a Centronics printer, you give it a character and then go pling, right, and say print that. Okay, well, if you've only got 8 bits, 7 of them is print this character, and the 8th one is bing. And if you want to have 8 bits as the character and something else going bing, that costs extra. So we said, well, we'll just take the 7. We'll take the 7 bits.
I was wondering if it was something AMSTRAD told you to keep something different from the. No. Okay.
Just to, as standard as possible. And I don't think that. Not many people want to print characters which are outside that 7-bit range, but you can also do scapegoats. You can say to the printer, "Hold on, here comes a complicated one," and then you can send it in 2 goes. So you can do it if you want to. Similarly, the expansion port is essentially a Z80 processor bus.
Yeah.
That's all it is. So if you can design anything to go on a Z80 processor bus, which lots of people can, you can design it in a box and plug it in the back.
Yeah.
So that's completely standard. The video socket is the same as the BBC Micro.
Yeah.
Because why invent a new one? Made no sense to me to invent a new one just on purpose, just to be awkward. And that's about it, really.
This prototype has a board inside that is not the gate array, but the board with the gate array
Yeah.
extended.
Simulator.
Simulator,
It's
yeah.
a simulator.
Mhm.
You did that because at that time you didn't have a gate array.
Yeah, exactly. We decided that we would put most of the logic chips, or most of the computing logic, into one single gate array. Okay, two reasons for doing that. Firstly, it's cheaper and simpler and easier because you just plug one chip in there. You've only got one chip to test on the production line. You've only got one set of holes to drill in the circuit board, all the rest of it. You can have a whole production run for a computer like this stalled because there's one or two chips which are in short supply. So if you go to a manufacturer and say, make us 100,000 of that chip, then you've got them.
Yeah.
Right? You're not sitting there waiting for one TTL chip that for some reason's gone out of stock everywhere. Also, although people have reverse engineered it now, then it was more difficult, and it meant it was really difficult to clone the computer.
Yeah,
All right.
that was a problem
So,
for us.
so nobody could clone it because the world was awash with Apple II clones. All right, and we were worried that if it was a success, people would clone it. All right, and therefore, if we put the logic inside a chip, it's kind of secret. All right, and you don't know what's going on inside. We printed, they were completely transparent in the service manual. We printed this diagram of the circuit board and everything else about it, but that one little chip is a little secret. Okay, and again, that's a good reason for using that. Now, those chips take about 2 months to produce. So you give the chip manufacturer the circuit diagram and say, there you go, make me some of those. And they say, I'll come back with 10 samples in 2 months' time. You know, it's like having a baby. You can't do it any faster. So,
is it true that Alan Sugar had to call Ferranti for the GA because it was there was a delay more than planned?
No, we all got on the train and went up there and shouted at them. So, no, you know, yeah, that was a very important part of the project. We literally got on the train, went up there and shouted at them and said, what is going on here? All right, you told us you'd have this ready and it's not ready. So what is going on? But in the meantime, we needed to have these prototype computers for people to write software with. All right, you can't write software just from a printed specification. Well, you can, but it's really difficult. There comes a point when you've actually got to test it on the hardware. Right? And also, we wanted people to trust us that the computer was actually ever going to be in the shops, because if you wrote a game like this, put a lot of effort into it, and then that computer never appeared in the shops, well, what good's that? All right, so what we said was, we will make a gate array simulator board which does exactly what the gate array does inside, but with a board full of chips. But we only needed 50 of each of the chips rather than 100,000 of them. So we used to sit around, well, we designed the gate array and sent it off, and then we designed the gate array simulator with a header with the same pin out. I remember we sat around in Medji's house in Dorking, soldering all the chips in and testing them, and his girlfriend, now his wife, bought us pizzas. And we just sat there and did it, because it doesn't take that long to solder 50 of those up, only a couple of days. And then you plug them in and they'll either work or they don't. Right, and at that point, if the gate array simulator doesn't work, you throw it away. Because you're not going to start working out which bit of it's gone wrong. So we started off making 50 of these. And we ended up actually with about 45 that worked by the time we'd thrown away 5 Gatorade simulators, 5 cassette drives, 5
right.
keyboards, because they didn't work. So we ended up with about 45 of them. And somewhere there was a list of who had each of those 45. And I'd love to be able to find that list, but I don't know if it even exists anymore.
And well,
One question about the prototypes.
Mm-hmm.
Were all exactly the same?
Yes.
Or do
all,
they have any difference?
No, they're all
between-
exactly the same.
They're all exactly
the same.
all
And the
right.
other thing we had was you put the software in a custom ROM. And again, that's not unusual.
Yeah.
Okay, all computers of this era have their basic software
Yeah.
in a ROM. But again, you give the code to the ROM manufacturer and he says, thank you very much, we'll send you some samples in 2 months' time. And you're going, oh, for heaven's sake. So we designed a piggyback board,
Yeah.
all right, with 4 EEPROM sockets on it. So the prototype software we blew into 4 EEPROMs.
Okay.
The reason we blew it into 4 EEPROMs is they were the biggest ones you could buy. Because of the technology, they could make custom ROMs much bigger than EEPROMs, right? So while we were going for a 32K
Yeah.
ROM chip, the big it must be, it's not 64K, is it? Anyway, whatever it is, the EEPROMs we used in there were the biggest ones we could buy for sensible amounts of money. I remember on a future product, which is not the subject of this interview, I bought some EEPROM, really big EEPROMs, direct from the manufacturer in order to facilitate this process, and they cost £5,000 each.
Oh my God.
And you're going,
A lot of money by that time.
it was a lot of money,
Yeah.
but I needed them. But that
Yeah.
was the biggest EEPROM in the world at the time.
Yeah.
Okay. Anyway, so going back to this one, so what we did was we laid out the circuit board, the motherboard.
Yeah.
Okay, and it's got 1 socket for the gate array and 1 socket for the 4 EEPROMs. And the gate array simulator board, and there's various pictures of them online, was rectangular, and it had the ROM chip in the corner and the gate array like a big L shape at the bottom. And then the ROMs arrived, and we designed this in advance. The ROMs arrived first. So what you did was you took a pair of clippers and clipped off the corner with the EEPROMs on and stuck the gate array simulator back in, and then a real ROM. And one of the things which I think it has become more lost in history is those 4 little ROM boards. There are very few of those around. I don't have one.
Okay.
Because what you did was you plugged in the ROM, and that works. So you threw the you threw the piggyback board with the 4 EEPROMs in it away. I mean, you might have stolen the EEPROMs out of it to use for something else, but basically, I don't need that anymore. I'm just going to throw it away. So I've seen pictures online, mainly with just the L shape.
yeah.
I think there's a very few that have got the original
shape.
EEPROM thing on there as well.
Oh,
The other thing we did, which really helped the project, particularly with Locomotive and designing the software, was they did their software design on an IBM PC.
Yeah.
All right, and you then need to get it off the IBM PC into the computer. And the way they did that was we had a EEPROM programmer, which we had to build an EEPROM programmer.
You build it.
We built it because, again, going back to what we did at Ambit, we were good at building hand-built
Yeah.
equipment, so we built an EEPROM programmer and gave it to them so that they could
Program the the basic interchange.
they'd type it on the computer, on
we
the
have
IBM
the
computer,
open?
they'd blow the 4 EEPROMs,
Yeah.
they'd plug the 4 EEPROMs into the piggyback board,
Yeah.
and they'd turn it on, look at it and go, yeah, that's almost right, but you know, we need to do this, or we need to do that.
Okay.
And they did that several times a day. You know, you'd go around that loop several times a day. So the final version of this, and we didn't actually keep a log of what version each was. So we didn't actually keep a formal log, I don't think, but the final basic and everything was probably like version 200 or something.
We're going to open the case, bubble plastic, to protect it. And you know what? When we first opened the case a few months ago, it was by November 2019 when Jorge got it. It was, you know, it has on the inside a lot of hairs, and but now this is clean and beautiful. I remember, I think that we have to dissolve two wires on the inside to separate the case, the top case, from the bottom.
Sigo yo por aquí.
Sí, dale. Ahí está. Ok, vamos a ver. Ahora. When we open a 464, we usually start on this side.
Yeah,
but the thing is that we have
then
here.
just need to flip it over so that you can.
We have here these two wires, you know, and it's a bit difficult if we don't dissolve these two wires. It's difficult to split it, but here.
Well, what I'd do, I'd unplug that,
Yeah.
and then just flip the lid over. That's the best way to do
let's
it.
do it
Can you plug that back in again?
slowly. I don't want to break the connector, you know. They say it's out of guarantee.
No.
Just 40 years.
You open it, it's okay.
So, I don't want
The
to.
straighter you can keep it as you're pulling it out, the better.
Yeah, but you know, Roland is well.
There you go,
yeah,
there you
it's
go.
okay. We did
Okay,
it.
right, and then
Yeah, and now
and then
we
try,
could the cassette, the tape deck connector.
Okay, and then you
Yeah.
there you go.
Here we are. So here, power
Hasta ahí.
switch. Yeah.
That's
Okay,
fine.
that's-
That'll do.
So Roland, tell us something about the
Well, okay. So
prototype.
so here, this is one of the ones that's had the 4 EPROMs clipped off.
Yeah.
So that would have been a board here with the 4 EPROMs on it. So that'll be the ROM chip,
Yeah.
and then the gate array will be under there. There'll be a header there that plugs into, and then each of these. So these are the kind of chips that you would have made.
Oh.
So these are very standard chips that you make computers out of.
Yeah.
Okay.
LS,
And then
PAL,
these are
PALs.
PALs,
Yeah.
which are fusible link, and they're there for 2 reasons. Firstly, because there are more gates in inside one of these than one of
Okay.
these. Right? I can't remember how many, but these typically have 4 gates or 8 gates inside them. Not very much. These might have 16 or 20.
All right.
Okay, so you can make the board smaller
simpler,
because there's
yeah.
more inside each one, but also what's inside these is a secret.
Yeah, we don't know.
Because what's inside these, you can read the label and look it up in a book.
Yeah.
Right, you can't do that for those.
Yeah, we know.
So again, it's a kind of a
Some people they say that they could do reverse engineering, and they might could read those PALs,
yeah.
PALs,
Well,
you know.
well,
But we'll see.
40 years later, maybe you can.
Yeah. So we're going.
So you need another big computer to help you reverse engineer it.
Yeah. So
And also, this clock
Yeah.
was intended to be not the same.
Right, the story about the clock is that the Ferranti gate array is you're supposed to be allowed to attach a crystal to it directly, right? But their technology didn't work. All right, so we had to add a little had to have an extra gate to tickle the crystal to produce the clock.
Okay.
And the guy at Ferranti, I'll never forget this, the guy at Ferranti, when we had the first prototype and we plugged it all in and we're up in Manchester, so we've gone up on the train to yell at them and say, what on earth's going on here? He came over, peered over our shoulder and he said to his colleague, that didn't work on the Sinclair Spectrum, I told you it wouldn't work on this either. So we just had to add that, and some of the really early prototypes have got this chip and that on another little header.
Yeah. Okay.
Which is because the board was originally laid out for a directly connected crystal, not an external oscillator.
Okay.
Does that make sense?
Okay. Yeah.
Yeah.
That's it. So
that's not.
That's the date.
That might be my writing.
Yeah.
I know. I've seen pictures of the 4 EEPROMs.
Yeah.
And all the writing on those is all my writing.
I was amazed to learn that at the end, the first game you received were the ones from Indescom, but they were the last company that received the prototype, because it was not intended to give them anything like this.
Yeah, I don't remember exactly how Indescom got involved. You'd have to ask, what's his name?
We'll tell you later the story. It's a nice story.
Yeah, but as far as I was concerned, I just made 50 of these, and other people then sent them off to...
Yeah.
Do you want to separate the Gator Race Simulator, Roland?
Well, I think it should just...
Just push... Yeah.
There you go, like that. See, no problem. I'd be happier if that wasn't on a bit of plastic, to be honest. Let's put it on the book. Okay, so that's a... This is the kind of thing that we used to sell at Ambit, these little headers and things. So we just had them and these sockets. So there we are. So you've got the gate array there. Those are the RAM chips. There's the CPU, which is in the socket. The reason you put the CPU in a socket is because they're one of the first chips to die usually.
I've replaced many of them.
So you need to be able to replace it fairly easily. There's the ROM chip. They're very reliable. The ROM chip is probably one of the most reliable.
Yeah,
that's I don't know if you looked at some early production whether they were soldered in or in a socket or not, but
they're not. They're not on a socket in the production.
No, right, okay. Model. I mean, some people prefer to have their ROM chip in a socket in case there's a version 2 ROM. And they can plug it in, but they said, well, we're not going to do a version 2 ROM. Well, we did actually, because of 6128, but so you could plug a 6128 ROM into here and it'd work.
Yeah.
Somebody was asking me which many versions of the basic, apart from 1.0 and 1.1, were. Because
I think there's only probably 3. There's the original one.
Yeah.
And then there was a bug fix a couple of weeks later which didn't go into production because it was too late. And then I think we must have probably done another one for either the 664 or the 6128, or maybe one for each of them. But pretty much 99.9% of the basic stayed the same the whole time.
Okay.
So there we are. So I mean, the design we were given, because Amstrad was good at what we call industrial design, right, making things look pretty in the shops and making things that you can easily manufacture. They came to us with this bit of plastic and this bit of plastic and this keyboard they'd done, and they knew that they wanted a cassette mechanism in there. They were familiar with the cassette mechanisms because they used to make car radios with cassettes in. Right? So it's the same cassette that's in a car radio. Okay. And they were already buying millions of these, so they were cheap and they understood them.
You can find that kind of cassette in a lot of different products, not just from Amstrad.
That's
everywhere.
Right. That's right.
They're everywhere in the 80s.
That's right.
Everywhere.
So that was it, and they wanted it to be a complete system. They wanted it to be the computer, the tape deck,
built-in monitor,
and the monitor, because they wanted it to be freestanding. They didn't want the person using the computer in the home, who would usually be a teenage boy, most of them. That was their target market. They didn't want him to have to go and borrow the TV because everyone else was watching that. They didn't want him to have to go and buy another cassette recorder, even though you could go around the corner and buy one anywhere, but they wanted it all built in. So that's what we were given. We were given this box here with the keyboard, with the bottom, and then all these holes drilled in it here. So they're all in the same place. So we had to when we laid out this board here, we had to make sure there were the holes in the right place so it would fit on top of it. And that's just for strength again. This is production engineering, is that you put these things here in the places, yes, almost exactly halfway down. So you put these where it's going to do the best job of holding it together if somebody drops it on the floor by accident or whatever.
So another question we had is regarding the operating system, is that it was your decision to ask digital research for CPM later?
Later, yes, because again, I don't think it figured in the original decision to go Z80, but by coincidence, digital research Z runs on 8080 and Z80. So when we got to a machine with a built-in floppy disk drive, because CPM's a floppy disk drive operating system, then it makes sense to say, well, let's buy some copies of CPM of digital research and bundle them in with the product, because what we didn't want is people ringing us up all the time saying, I've just bought this copy of CPM, one copy of CPM, and I'm having difficulty writing the screen drivers or the disk drivers or something, because at that time you were supposed to do that yourself. And so it was just so easier for us just to do it once and ship it with the product. And that sort of saved us time and money in the long run, even though it cost us a little bit to buy the licenses. But again, I mean, these components here,
capacitors.
These are the things we sold in our shop.
Oh, right.
Exactly the things we sold in our shop.
They're still alive, they work. You know, they're pretty reliable.
These are the ones that
you know,
that
the electrolytic ones.
Yeah,
I didn't replace any of those.
No?
And I fixed thousands of Amstrads, you know. Well, not thousands, hundreds.
But they're the ones in...
They're pretty reliable.
In the Amstrad boards.
In the Amstrad boards.
Yeah,
not in other computers.
But old IBM PCs and things, they
Amstrad,
always go.
They are pretty reliable, you know. Yeah.
Nothing Commodore.
And these are proper full size resistors, you know, hand soldered in. Nowadays you have these tiny little ones which are almost impossible. You can't hand solder them.
It's more difficult. And you know, nowadays the most problematic thing maybe the RAM chips.
Okay.
Yeah, they're pretty. They blow pretty often. And then I've replaced a few of Z80s.
Yeah.
We have plenty of them from China. They cost like €1 each, so they're pretty cheap. And the RAM chip is very reliable. Yeah, I might have been. I think I replaced one, but they are not. And the sound chip is also, I have replaced one because I think they short circuit or something, the keyboard or...
Again, I mean, the sound chip is a perfectly standard one.
You know, this sound chip, I love this chip tune. I love it. I really love it. Yeah. And you know, the rest of the components, they are the LS, they are pretty reliable. You know, so you made a very.
And these are all very standard one. Then none of them are particularly awkward to get or whatever. See that on there. It says Crystal 1.
Yeah. For the crystal.
Right, so originally, the crystal would have connected direct into here.
Yeah.
But on the gate array simulator, we don't have a crystal in there, we have it there with the circuitry for it. And there's some early prototypes where we have to basically take that circuitry there and put it on a little header board here to feed the clock into it. And these, I mean, you know, this board itself went, you know, this is the prototype board. There's probably version 2, version 3, and then when it went into production, which is when I start losing interest in it, then this board they'd move it around and shrink it and do all sorts of stuff to it, but you know, it's not my particular interest, to be perfectly honest.
So we can go for a tour. So we are making a tour by the different models of AMSTRAD products here, and we have the 464 here, then the 64. Do you know how many units were produced?
Not very many. It was only five or 10,000, something like that.
People are saying 10,000.
Yeah, something like that. But again, nobody ever told me how many of these.
Yeah.
I mean, they sort of said, "Oh, you do realise we sold 3 million of those, don't you?" And I say, "Really?" But this one, nobody ever told me.
This is the most beautiful one, man. Beautiful, really beautiful. Do you know if this design of this 64 it was inspired on the MSX computers or something, or it was?
I think this is probably an attempt at an MSX type thing.
Many people think that.
So the prototype of this was one of those with that end sawn off and a DDI one was literally glued on the side of it.
There was a prototype without this one? No. Do you think?
Yeah, there's a prototype 664, but say rather than looking like this, it was one of these with a disk drive kind of glued in place of the.
You know, Roland, we call this model. This is the CPC 464, the earliest one from 1984, and we usually in the fans we called it high keys.
Oh right, yeah.
Because those keys, you know, they are higher than the later one from 1986.
Okay. All right.
You know, if you look at them, this is this key, and this keyboard. It has a very good quality. It has a PCB under the keys, and there you have a membrane that has a membrane underneath.
Okay.
Can you say something good about this model? This is
Well, I can't say anything bad about it because
this is the one intended for the Spanish.
Yeah. Because you had some kind of strange. Import controls on 64K computers, so we made a 72K computer. But you see, at that point, I'm not involved.
Yeah.
All right, because I've moved on to the PCW and other things like that. So you don't need me to help you design a slightly different looking keyboard or add another 16K of RAM into it. If people do that for themselves. So that's our
the
printer, yeah.
And
but we moved very quickly on from that because about the time that was released, we hired a distributor in the United States.
Right? Sears might be. It was Sears.
No.
Sears.
It was in the Scomp.
In the Scomp by
Dominguez and Jaime Perón.
Yeah, sort of in Discomp.
But I think that Amstrad computers were sold on Sears.
Yeah, they
stores.
were. Yeah, they were. Yeah. But the distributor looked at 664, which is our latest new thing, and said, well, that's no good because nobody here is buying 64K computers anymore. They have to be 128K. So we rushed this one out originally for the American market because they said, well, we just simply can't sell that. Nobody will buy it. So we rushed this one out mainly for them.
You know what, Roland? On the European models, you use edge connectors for the expansion ports and for the printer, and on the American model you put here Centronic connectors that are they're really good.
I think some of the German ones had those as well.
Yeah, of course.
But that's just an electrical safety interference thing. Regulation thing.
Some Solabox computers ended up here in Spain. I don't know why, and you can find some Solabox units here.
I didn't know that.
Yeah, the original ROM. There's 4 links on the circuit board where you can change the name that comes up here.
Yes, Schneider or Amstrad or Orion, I think.
Yeah, Orion, Schneider. Yeah.
For Australia.
So these are all people that we thought might sell them. So I think Solarbox was one of those. We had no idea whether they were actually ever going to end up selling them, but we thought, well, we had, we've got 4 spare pins on a chip, and Might as well use it for that as anything else.
Jorge decided that we should see here this game, which is
All right.
a new one, very advanced technically.
All right.
That's a homebrew game, you know, and it's unbelievable to see that on Amstrad CPC, you know. The scrolling,
All right.
look at this, how
Yeah,
soft it moves.
Yeah.
It's awesome.
Soft vertical scrolling.
Mm-hmm.
What do you remember about Arnold number 2?
Well, the thing about on number 2 was that people would introduce the word processor, okay, which is just black and white, and quite a lot of people said, well, why doesn't it play games? Why doesn't it do colour? I said, well, you don't expect to play games on your vacuum cleaner or your microwave oven. You know, it's not a computer, it's a word processor.
Yeah.
But people just refused to believe us, and they said, well, it's got a Z80 inside it, you must be able to play games on it. I said, well, what if your vacuum cleaner's got a Z80 in it? You wouldn't expect to play games on that. But anyway, so we eventually said, all right then, what we'll do is we'll develop a version of the PCW 8256 that's got 64 colours. And so it'd be the PCW, it'd be a 64 colour PCW, and it would be backwards compatible with the 27 colour. Right, so you could almost literally have a switch on the side and say which one you wanted it to be. But we were so busy that we produced a prototype, but we just didn't have the time to...
There was a prototype.
Oh yes, yeah. But we're so busy with other things that we just got to the point one day that we just said haven't got the hours in the day to do all this. So one of these things has got to go, and that was the one.
Oh.
So it wasn't because it didn't work or we didn't expect people to buy it. We just didn't have the man hours to bring it to market.
Oh.
So, I mean, I think it was potentially a good machine.
Yeah. Sure.
It would confuse people if you had a word processor that you could play games on, but and that's always a danger.
Yeah.
Saying, well, actually, you're confusing your market here. What is it? Is it a word processor? Is it a CPM engine? Is it a games machine? And people like certainty in life. And they say, well, I want to buy this because it does that and it does that well, and I don't care. If I want to do this other thing, I'll buy something else to do that other thing. I don't really want something with a big switch on the side where you can turn it from being a vacuum cleaner into a microwave oven. It's just too complicated for me.
Yeah.
That I had nothing to do with at all.
You were not involved in any of this.
No, well, actually I was. That one not at all, because I was doing other projects and I had people on my team who were perfectly capable of doing that. This I was involved in because it has copy protection on the cartridge.
DAC.
And it's very complicated. Technically, it's very complicated, and so they got hold of me to work out how to do the copy, because the people doing the games said we will only write games for this if it's got copy protection on the cartridge, otherwise they'll just get pirated and stolen. So we had to put in copy protection, and that was complicated, and so I got involved in doing that.
Do you remember why some games were taken off the shelves?
Nope, no idea at all.
Okay. So definitely you were involved in this one.
Oh yes, yeah. So this was what we did after at the same time as the 6128, roughly. So we're doing like one machine a year. So the first year was the 464, the second year was the 8256, the year after that was the PC 1512. So we very strictly sort of one a year. Now it turns out, again, enormous coincidence, all right. Medji's dad who Richard Clayton worked for, doing software, and some of their team, his dad owned a company that made word processors.
Yeah.
They're big, huge
Yeah.
things, size of a desk. With a
Diamond.
with a big screen and a Daisy-Wheel printer and all the rest of it. Cost a fortune. People like banks used to buy them, and they'd write letters to people saying, "Dear Sir Perry, you owe us lots of money. When are you going to pay it back?" And so that's why. Well, that's why Medj, although he's always been an engineer. That's why he was involved in designing things, because he designed the hardware for the Diamond, and Richard Clayton and some of his friends designed the software for it. So when who came back saying, I think we need to do a word processor, I said, well, that's a coincidence. I know exactly the people who can do that for you, and by the way, you've already met them. So they did that, and so the software for this is basically the Diamond software, which they'd already done. So it took them hardly any time at all.
And it was, you were calling it Circon, but...
Well, this is one of these funny things. We're always coming up with these code names for things. Like, for example, the 464 is the Arnold.
Yeah.
All right. The 664 is the Idiot.
The idiot?
Idiot includes disc instead of tape.
That's great.
We didn't know that.
Okay.
The idiot.
Yeah. This is Joyce, because he said to us, it's got to be so simple to use that even my secretary will be able to write letters on it. Which I thought was a bit disrespectful, frankly.
Yeah.
But anyway, so that became known as Joyce. In Germany, they sold it as Joyce. They actually used the code name to sell it. So that's the Joyce. The original one, of course, this has had a second drive added. The original one just has one drive in it. Because it was only the 8512 which was shipped with 2 drives. And the second drive is double-sided, double density, so it's got it records a lot more information on it. But frankly, it would take you a month to write enough letters to fill up even one of these. So it's people would say, well, why do you use such a small floppy disk in terms of kilobytes? Well, because it will take you a month to type enough letters to fill that up. And secondly, this format wasn't very popular.
Yeah.
I have to agree, but you needed a disk drive in it. Okay. Now, this was designed by the precursor to Panasonic.
Yeah.
All right.
Matsushita.
Matsushita. Matsushita, I think they call themselves. Okay. And it's very robust. It's not completely waterproof, but the idea was that you could write someone's address on here, stick a postage stamp on it, and put it in the letterbox and send it to somebody. That was their kind of bright idea. I don't think anybody ever did that eventually. Anyway, so they designed this standard, but nobody wanted it because there was nobody in the market selling home or small business computers who thought that using their format was a good idea. All right. Sometimes you invent something and nobody wants it, and this is one of those things. So, but I needed, we'd used it in the DDI-1, all right? And as I said to you earlier, the DDI-1 came out before the launch of the 464. It was very, very early. So one of my jobs was to go out and find a disk format, and there were 4 that I think we might have used. 5¼ inch floppies, no good, too big, too fragile, too expensive. There was a 2-inch floppy.
2 inch?
2 inch, basically the same as a 5-inch floppy, but just shrunk.
All right.
Okay, so I got one of those, and I thought it's still got these kind of issues with the media, and it's not very, it's not very robust and all the rest of it. So and nobody's using it, so don't like that one. There was a drive which is essentially the same as the Sinclair microdrive, right? So a little tape,
like
continuous tape
right.
thing. But the microdrive, Sinclair microdrive, had such a bad reputation.
Yeah.
All right. I said, well, we can't ship something with a microdrive clone in it because everyone will just laugh at us. And then this was the only other thing that was available.
3.5 wasn't available by that time?
No, it was about 3 years later that IBM chose it for their computers. Before then, a few companies had chosen it, but only for very niche applications, okay, not for mainstream applications.
Sony SMC computer, which was very uncommon computer.
And it was very expensive. Again, the drive cost more than the whole computer, right? The other funny thing is that because they wanted to put more data on the drive, it went round at a different speed depending on how far the head was out. So the closer it was to the middle, the faster it spun it. Okay, it's really difficult to make a controller for that. Right, it's a complete nightmare. These drives and this media is absolutely plug compatible with an IBM PC 5.25 inch drive. Right, you could take that out, plug in an IBM XT drive, and it will work. Okay, or vice versa. You can plug one of those into an IBM XT and write these disks. And one of the formats, if you look in the manual, on the formats, you've got the 464 or 664 native format, and you've got IBM format.
Right. There are a lot of formats.
Yeah, the IBM format is lower data capacity, all right? But it means you can transfer stuff from one machine to the other, which again is invaluable for software developers.
Yeah.
Right, so you can design your software on the IBM PC, write it on a cross compiler on an IBM PC, pop it onto one of these, stick it in there, and try it out. And 5 minutes later, you know whether it works or not. So
Spanish companies decided that it was a good idea to produce games for the PCW. This is the game. Yeah, actually.
Excuse me, that's a cassette.
You can for the full system, disc and cassette.
Oh right, okay.
Yeah.
And there are a lot of them.
Okay. Well, whatever floats your boat, I suppose.
But one thing we find nowadays is that these discs, the floppy, just has one head. So the thing is that on the other head you have like I don't know how to say that in English. It's like a little piece that pushes here, the disc, and after a few years, this piece it breaks or and it scratches the discs, and they all are dying because of that, because because of that piece. And if it were like double-headed, it wouldn't happen, but it's happening. So we don't have too many of these discs available, and they're expensive nowadays. Yeah.
Like I've got a few.
10 euros each.
Sell them to.
Maybe,
I'll sell you some. Okay.
So you were involved in
yes,
this one?
Because by this time we had lots of foreign distributors, and we had about 20 countries selling them. So what you need in a country is foreign characters like your Enya or a Cisadilla or a Icelandic thorn was on the ones that I quite liked. So we had different character sets to different countries, and we had people translating the manuals into all the languages as well. So that needed coordinating, because we also did software in lots of languages. Okay, at the time IBM was doing MS-DOS in English, French, Italian, German and Mexican. They said it was Spanish, but my Spanish translator said, no, that's not Spanish, that's Mexican. Anyway, but we did more than that. We did the first Russian IBM PC.
Hebraic, from Israel, for Israel market.
I don't remember doing one for Israel, but anyway, so I was involved in coordinating all the people, and had all these translators working for me, and people flying in from all over the world, and I'd go because particularly Microsoft error messages, because by then we're getting onto the Microsoft PCs, are really difficult to translate because they don't take account of gender. Right, so when they say the floppy disk isn't working, or they say the printer isn't working, if they're doing cut and pasting messages, there's a problem if floppy disks are female and printers are male. It doesn't look right. anyway, that I've nothing to do with.
Not with none of them.
No, nothing.
One thing about the PCW is that it was sold in the United States. Or no, don't think so.
Well, it was after my time.
Okay.
Right. So then we have this, which actually, you see, if IBM had chosen the 3.5-inch floppy by then, we'd have stuck a 3.5-inch. But it was a couple of years before they were actually going to make that decision. I think it was the PC Junior or something was the first one where they actually said, well, let's take this leap of faith and go from this format we've been using for the last 10 years to a smaller one. So, yeah.
So in this one, you were involved.
Oh, yeah.
Which was the latest PC you were working on?
Well, that was, we used the same team, particularly on the hardware design side, to design that. Yeah. So, and then of course the 1640, which I think the 1512 had either a floppy or a floppy plus a hard drive. I don't think we ever did a twin floppy 1512, but I could be wrong.
Yeah, originally I think so.
But a 1612 would have had a hard drive and a floppy in it. PPC, I've got one of those. This, again, very misunderstood. Okay, people think it's a laptop. Right, stick that on your lap for 10 minutes and you wish you hadn't. All right, it is not a laptop, it's a luggable.
Yeah.
What you're supposed to do is exactly what I've done on this trip. I bought a luggable laptop.
Yeah.
All right, and you put it in your luggage, you carry it around, you put it on a desk when you get there.
Yeah.
All right, and you use that screen there to configure the monitor there, and then you use it.
Yeah.
You're not supposed to use that for doing anything sensible.
Yeah.
It's just so you can get the thing started. And we went to a show I'll never forget, we went to a show in the United States, and all these people looking at it and going, well, that screen doesn't look very strong. And literally people would come up and pull the screen off. And they'd say, look, I told you it wasn't very strong.
So Roland, talking a bit more about the 464 model. This is the latest model,
right, okay.
you know, low keys. And if you look at this,
and you got the
brand new,
got your Spanish key there.
Yeah, Spanish ñ, new logo.
All right, okay, fair enough.
And this is we call, or people usually call it, the coast down model.
All right,
because you know the board is shorter.
Right, okay.
We have here the video and the power supply, you know, an expansion port. And were you involved in this new design?
No. Once I've delivered version 1 that works, okay, I had very little to do with the keyboard layouts. I had a bit to say about the PCW, right, saying, could we just do that and the other? But I didn't have really anything to do with the cosmetics, what they look like, right? How you later on decide to have different coloured keys or shrink the board to make it cheaper to build or anything. That's all just ancient history. I deal with these from about a year before they're born to about a year after the first one in the series. And then I've got other things to do. So I always talk about it, it's like an airport. Okay, you've got one plane taking off, one taxiing onto the runway, and one flying down, which rather hopes the one that's on the runway's left by the time it arrives. So, do my air traffic control thing. I'm only interested in those 3 planes. The one that's on the runway now, the one that's just taken off, and the one that's just coming in. The one that took off half an hour ago, I'm not interested in. Well, I haven't got time to be interested in it. You know, I haven't got enough hours in the day to be interested in it.
So we are very happy to have you here.
Thank you.
As a film
I'm delighted to come. I really am.
As a film director, traffic controller. Thank you very much. And that's all.
Okay.
We will see you tomorrow in Retro Alacant.
Okay.
Yeah, and thank you very much, Roland.
You're welcome. Did you know that is the only picture of me that exists in the lab?
You told me.
That was our lab there.
Sí, vamos a... Roland nos va a firmar el 664, ¿vale? A la parte de atrás.
A dedication.
To my friend. Where you want. Or for my friend.
Enseña.
So.
Enséñala otra vez, que parece eso. Mejor la seguridad social. Awesome. Y ahora si me miráis a mí mejor. Aquí.